Okay, you ready? So we did this. Okay, let's develop our 3 points here. 3 to the -1, 3 to the 0, 3 to the 1. So you always start like that. The base is 3. So 1/3, 1, and 3. So there's my coordinates. -1, 1/3, 0, 1, and 1, 3. So if I was to graph there you go. So what did we say were the basic things? We said the anchor point is 0, 1, unless it's transformed, like left or right, up, down. Your asymptote is always y = 0 until it's transformed. And another coordinate is always 1, the base. Okay, we did this on Thursday. We started, what is a log? So a log was us working backwards. So I'm just going to give you a super quick recap here of what we did yesterday. Do you remember something like this? Okay, what does this make us do? What is the base, result, exponent? What's each component meaning? 5 is the what component of that? 5 is the base. 25 is the what then? Result. So what I'm doing in my brain is thinking backwards, right? So then I'm getting a 2. Okay, versus exponential people would do this. This would be considered the input, and this would be considered the output. Okay, input, I'm inputting a 2 and I get out a 25. Versus logs, this is what happens. Input, and my answer, which is the exponent, is the output. So I'm always just flip-flopping my brain around those ideas. And your brain really likes to think this way, input, output, but now you're going to have to go backwards with that. Okay, so that's all logs do to exponentials, is flip-flop that idea. Okay, so that being said, looking here, x is now the result and y is now the exponent. Versus x is the exponent and y is the result. So do you see what has happened here? They've changed places. Okay, so what does the graph look like? This will now be the coordinate 1/3, -1. This will be the coordinate 1, 0. This will be the coordinate 3, 1. So see if you can figure out how to plot those points and what it might look like. So there it is, and then I'm going to curve it. And where's my asymptote? Now, guess what? It's going that way. Right, do you see it? It's going this way this time. Okay, so let's see here. This will always have the anchor point 1, 0. So there it is. Instead of y equals, this is now x equals. And this coordinate will now be the base, 1, which is here, 3, 1. Look at that, how it transformed. Anybody know what the next good coordinate I would pass through on my way? Going, what was the next good coordinate I would get to? Nine, 2. Because 3 squared is 9. So that's the next good coordinate I get to. What's the next full coordinate I get to? 27, 3. Okay, let's do another one. What's the base? 5. So 5, -1, 5, 0, 5, 1. One-fifth, 1, and 5. Okay, this is a log graph. So, input, output. You ready? The first coordinate is going to be 1/5, -1. So do you see the difference? That's the only thing I'm changing. Instead of exponential, I'm writing that with the output first and then the input. 1, 0, and 5, 1. So just a super quick sketch of what a basic log graph looks like. Okay, now we have some stuff that goes on ABCD stuff. So I'm going to think about that and that. What letter do you think those things are? A and a C, good. So I'm going to be doing an x plus 2 and a -y to those coordinates. Those coordinates are all going to be doing that. So 1/5 plus 2, I'm just going to go 2 and 1/5. And now this is +1. One plus 2 is 3. 0 stays at 0, right? And 5 plus 2, so now that's 7. And now this is -1. Oops, I ran out of chart here. I'm just going to actually think about my asymptote before graphing here. I remembered my asymptote should be right here, but in a word sense, what's happening in words to this? It's moving how so with a word? Right. So that's also going to make my asymptote. And then does it make sense the way the points are going? My asymptote would move to the right. Okay, I'm going to do one more today, and that's it, then we're done. Okay, Does anybody remember this? There is no base written in there at all. So now I don't know. But there's a secret base. Do you remember the secret base that gets used? 10. Okay, so we're going to quickly go through our 10s. 10 to the negative 1, 10 to the 0, 10 to the 1. Always start the same pattern. 1/10. Bless you, bless you. 1 and 10. So these coordinates, because this is a log graph, I'm going to go 1/10 and then the negative 1. 1, 0 and 10, 1. Okay, we are actually not going to even bother with graphing that one. We're just going to go straight to the transformed graph here. Okay, transformations. We have a couple things going on. We have this and we have this going on. So 2 things we're going to have to worry about, but I tricked you. Some of you might have fallen for my trick. What's my trick that I tried to pull? It's not factored out. There. It's going to reflect and move right 4. It's going to reflect and it's going to move right 4. So you know what we're going to do? We are going to put our asymptote on there. It moved right 4 now because of we had to rewrite this. Okay? How many people would have fallen from a trick? Would I have caught somebody? I'm sure I would have caught half of you because it's been a long time. Okay, we need to do x divided by negative 1 plus 4, and we have to do nothing to the y. Right? Are we good? That's the b, that's the c. How about we split this in half? I'll do all the work with the y's and you guys do all the work with the x. Sound like a deal?
That's a good deal.
It's right in half. Okay, I will help you. Oh boy, here we go. We have negative 1/10 plus 4. So think about 4 subtracting 1/10. You get 2, 3 and 9/10. Negative 1 plus 4 is 3. Negative 10 plus 4 is negative 6. Whoops, did a wrong point again. Okay, so remember what your basic log looks like, and now look at this as reflected, right? Do you see that reflection? So here's your basic looking log. Yeah, I see a reflection and I see a right 4. I can visually see those 2 things that have happened.